Rationalize each denominator. Assume that all variables represent positive real numbers. The first step is to use the quotient rule to separate this radical. So we're going to get the cube root of 108 m cubed at the top, and then at the bottom we're going to use the cube root of n to the fifth. So remember, that rule states that if you have the nth root of a over b, that's equal to the nth root of a divided by the nth root of b. That's the quotient rule. Now, remember, to rationalize the denominator means to get rid of this radical sign. So if I do the prime factorization of n to the fifth, okay, or that means we have 5 n's. So 1, 2, and we want to get them out in groups of 3. So this would be one group, and then this here we would be missing 1 n so that we can get this one out. So from here we would get 1 n, and from here we would get another n. So to rationalize the denominator, we need one more n so that we can get all of them out. So I'm going to multiply my top and bottom by the cube root of n and then the cube root of n. Remember, this is like multiplying by 1, so it doesn't affect my answer. So at the top I'm going to end up with the cube root of 108 m cubed n, and at the bottom I'm going to end up with the cube root of n, and then I have 5 here and 1 here, so that gives me n to the 6. So now the bottom, when we take the cube root of n to the 6, that's going to equal to n squared. And notice that we no longer have that radical sign. So remember, we take this 6 divided by this 3 to get this 2 here. Or we can just look over here, n times n gives us n squared. Okay, now we have to simplify the radicand in the numerator. So we take 108 and we do the prime factorization for that. So divide it by 2, the smallest prime number. And then that gives us 54. We take 54 divided by 2, and that gives us 27. 2 no longer goes into 27, so we go to the next prime, which is 3. 27 divided by 3 is 9. Divided by 3 is 3. Divided by 3 is 1. And we're looking for groups of 3. So this set of 3 3's goes out, and these go back into the radicand. So we have that 3, and then this is my cube root, and then these 2 go back in there, so because they can't come out. So 2 times 2 is 4. We have 3 m's, and we want them in groups of 3. So this is going to go out. So there's our m, and there's nothing that goes back in there. And this n cannot go out because it doesn't have a group of 3. So that goes right back in there. So then our answer is 3m cube root of 4n all over n squared.